Hey guys, thanks for tuning in again, and today we're going to talk about deposition today. I'm going to start out with a example which many of you might see in your areas where you live. If you have an inlet next to you, all right, so an inlet is basically an area where the water goes into a harbor or a bay. If you take a look at both sides of that inlet, one side of it, you notice the beach is very small. The other side, you notice the beach is kind of expanded out. That's not a coincidence, right? So you guys know sediment is going to be transported down the beach, right? We mentioned something called longshore current. So one side of a jetty, there's always going to be erosion. The other side, there's always going to be deposition. All right, so let's see if we can figure out the longshore current direction. So if you're looking at this diagram, see the jetty here sticking out? That's key to figuring out which way the sediment's going, right? And clearly you can see from here, the way it would be going by the longshore current is this direction here. Right along the beach that way. And that makes sense because on this side of the jetty, you can see the shallow water. This is deposition. So it's basically hitting against the jetty and getting dropped there. And then on this side, it's going to be eroded away. And this is actually Shinnecock Inlet in Hampton Bays, New York. I grew up in this area when I was younger. And this area here on this side always has to have sand pumped onto it because, again, this beach will get taken away by the erosion that happens all the time. All right, and here's a very extreme example also. I'm not sure where this one is. Definitely looks like a warmer area, maybe Florida or something. But again, longshore current is taking over here. All right, you see the one side is clearly a huge beach. So this is deposition on this side. Erosion is happening on this side, a little tiny beach. All right, longshore current is this way. All right, doing that exact pattern. All right, so you'll always see that with any jetty or what's called a groin. A groin is basically where they just do it off the shoreline. West Hampton Beach comes to mind with that. They call them jetties, but they're really just groins, what they call them. They stick out from the shoreline. They were a way to try to get the beach to stay. And the one neighbor, unfortunately, the one neighbor gets the beach, and then the neighbor next to them ends up with erosion happening, and they get mad because they lose their beach. And that they kept making them. So there's a whole line of groins out in that area trying to combat erosion happening in that area. But it doesn't work out great, unfortunately. So no matter what, you still have to pump sand on the beach eventually to restore the beaches, otherwise they go away. All right, so deposition is the dropping of sediment, also known as sedimentation. The process by which sediment is released, settled from, or dropped in an erosional system. It occurs when velocity or carrying power decreases. And obviously, the heaviest of sediment, like boulders, cobbles, pebbles, are going to get dropped first. All right. All right. Dissolved minerals precipitate out or fall out of solution occasionally when water evaporates. And that also can form deposits. So you see salt deposits here from evaporated seawater. Here's actually deep under the ocean. We found these. These are called black smokers. All right, they're basically dissolved minerals that are coming out of the earth at very high temperatures into the water. And we notice that also they settle out onto the ocean floor all the time. So that's called precipitating when that happens. All right, also large bodies of water is where final deposition is going to occur. And you notice there's a triangular shape there. All right, whenever you see that triangular shape, all right, we call that a delta. All right, so deltas form at the end of rivers or streams. The bigger the river, obviously, the larger the delta is going to be. So these are the two largest rivers in the world, the Amazon and the Nile, which both have very large deltas. All right, and these areas flood regularly, and you can see the sediment basically gets transported to the end and deposited deep out into the water. There were animations here. Unfortunately, I cannot play them anymore. Basically, I'll go over how different things affect the rate of settling time or settling rate. Okay. So you see these terms, settling rate, settling time. They're completely opposite. Settling rate, you should think of how fast something happens. Settling time is like taking a stopwatch. That's how long it takes to settle. So size, the larger particles are heavier, have more mass, and will settle faster than the smaller particles. Okay, so as particle size increases, settling rate increases, or as particle size increases, settling time will decrease. You see the difference? Okay, something that goes fast will take less time. Shape, on the other hand, the rounder sediments will settle faster than the flat sediments. Okay, so you can clearly see that on the bottom left graph. So round is greater than flat. And then time is the opposite. So round take less time than flat, because the flat will kind of flop around in the water. Also, the water has to go around that flat surface, so it takes longer for it to settle down to the bottom. Density, higher density particles settle faster than low density. So again, you increase density, you increase the settling rate. If you increase density, you decrease settling time. All right, so again, opposite relationships with rate and time. So be careful of that, actually. And velocity, as velocity of the stream decreases, the particles of greater density will settle out first. Colloids will move the same velocity as the stream, which we talked about. And the heavier, larger, flatter particles move slower than the stream and will be deposited earlier on. Okay, so, and that's, all right. And then a couple things about streams just to also take everything home. So a stream in balance is when all sediments have picked up in the stream by erosion are eventually deposited. And one that's in dynamic equilibrium has reached a point where deposition rate is equal to erosional rate. All right. So the stream is straight, eroding downward. All right. So again, early on in the stream's life, that's typical. As it matures, this will change. So a mature stream, the erosional part of a stream, is always considered the high velocity part. So those are the areas way upstream, up in the mountains. Okay, regions of steep slope outside of stream bends is where you're going to have erosion happening. Depositional part is where there's a decrease in velocity, no velocity. Okay, so if it stops flowing, obviously it's going to drop all of its sediment eventually. Rivers become wider as they get older. And the reason why, the meanders will start getting wider and wider. Okay, due to the erosion on the one side, deposition on the other side. And so inside of stream bends and stream mouth, where it ends up opening up into the lake or ocean, where the delta is, you're going to have a lot of deposition happening. All right, so again, don't forget that delta or fan-shaped deposit at the end of the river. Okay, so here it is. So here's a meander, And again, I mentioned inside a stream, deposition. Outside of the stream is erosion. You can clearly see it here. And eventually, sometimes what will happen is these two areas that are eroding will meet up and make like a circular lake called an oxbow lake. Also, it could make other paths for the rivers to flow in. All right, so eventually you end up getting a much wider stream that's flowing in much different directions. You also get what's called tributaries, which are little branches off the river in each direction, and that's what happens. So erosion again on the outside of the turn, because of that's where the faster water is. All right, higher velocity. All right, and that's it. So again, thank you guys for tuning in again. See you next time.